Hi, Mishler Math Kids. We are going to talk about exponential growth and decay. An exponential equation or function is something like this. Let's try f of x equals, let's say, a to the x power. Okay? Notice that in an exponential function or exponential equation, you've got your base is a fixed number. Okay, this is a fixed number, and we call that the multiplier. And your variable, excuse me, is up here, is your exponent. And oddly enough, that's why we call it exponential growth and decay, or exponential function. So anyway, we're going to talk about exponential functions. Let's start by talking about bacteria. Now, you know that there's good bacteria and bad bacteria, but bacteria grow. So let's suppose we get a little dish in our biology laboratory, and we start out with 25 bacteria, and we know that they're going to double each hour. So let's see what that gives us with our graphing calculator. Now if we push in 25 and enter, and then times 2. This is a kind of a cool feature with this calculator. We can just hit enter, 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 and it keeps doubling. Okay, so answer times 2 is 50, of course. You double that, you get 100. You double that, you get 200. Double that, you get 400. 1, 2, 3, 4, 5. Obviously, in no time at all, you got 12,800. And so, how do we do that? We started with 25, and then we doubled that, and we went 50, and then 100, and then 200, 400, 800, 1600, 3200, 6400, and then 12,800. We just doubled it each time. So you see, this is the first, this is at 0 hours, this is at 1 hour, 2 hours, 3, 4, by the way, this goes to here, 5, 6, 7, 8, and 9 goes to here. So after 9 hours, you get 12,800. Now, how can we make an equation that makes this work? Well, let's take a look. What happens if we said 25 times, because we're going to double it, so we're going to multiply it by 2, but we're going to do that to the x power. Okay? So this is basically our equation, y equals 25 times 2 to the x power. And let me show you how that works, okay? Oops, try this. So I got 25 times 2 raised to the x power, okay? So I'm going to graph that, but first I'm going to create a window, because this is going to go up high. I can't make a window go up to positive 10. So let's just make this go to, let's say negative 2 to positive 10. That'll be good enough, because we went up to 9. And so that's okay. The x scale is okay. So let's look at the y scale. Negative 10, and we have to 12,800. So let's make it negative 100. And then make this positive, let's say 15,000. Now I don't want to make my scale at 1, there it's going to just be a solid bar. So anyway, I'm going to make the scale at like 1,000. Okay, so let's graph this thing now and see what we get. Okay, now this is very common. Look at how it shoots up there because it's doubling each time. This is very common with an exponential. We call that a skateboard ramp. That's what we use to describe the scale, or the graph. Take a look at that, how it just, like a skateboard ramp, it just starts going up like that. Okay, so let's see if we can trace. And at x equals 0, let's hit enter. And y equals what? Equals 25. It barely above the x-axis there, isn't it? Because it's the x-axis goes up to 50, or the y-axis goes up to 15,000. So 0 and 25. At 0 hours, you got 25 bacteria. So then at 1 hour, enter, you get 50 bacteria, like it says here. And then 2 hours, you got 100 bacteria. 3 hours, 200, and so on, so you get 9 hours, and you're way up here at 12,800 bacteria. Okay? Yes, you're going to have to sit down and count individual bacteria. Yes, this is just a mathematical model. This isn't really what happens. So, at any rate, we have now an exponential expression here, or exponential function, and we have the fixed multiplier right here. This is our multiplier, and this is our exponent. Okay, so let's try something interesting here, and this is, we're going to try to figure out the this is a good thing for Mishler math students. What happens? How long does a body take to get rid of caffeine? So I'm going to clear this out here, and we're going to try to figure out caffeine. Caffeine. The body gets rid of caffeine at the rate of 15% per hour. So if we get rid of the 15% per hour, watch. If you start off with 100%, okay, you subtract 15%, what do you get? You get 85%. So at the end of 1 hour, you have 85% of the caffeine remaining. Well, from this, I can get a multiplier. Remember, a multiplier is the base for my exponent. Okay, a multiplier, in this case, let's suppose we start off with caffeine. Let's say we start off with 30 milligrams of caffeine. So 30 times 0.85 to the x power. That's going to tell me how much caffeine I have. X is the number of hours. Okay? So that's going to tell me how much caffeine I have in my system after X hours. So let's see what we have here. Now, if X equals 0, 0.85 to the 0 power equals what? Equals 1, right? And remember, anything taken to the 0 power equals 1. So at 0 hours, I have 30 milligrams of caffeine. So when I finish that nice, fresh, hot cup of coffee in the morning, I have 30 milligrams of caffeine, which is barely enough for me to keep my eyes open. All right. So let's see what happens after an hour. And by the way, you're going to find out why I have to keep drinking coffee all morning long. Anyway, so 30 milligrams of caffeine. So let's take a look at the graph, at the thing here, and graphing calculator. We're going to go back here, and we're going to say 30 times 0.85 raised to the x power. Now I don't think I want to go up to 30,000 here. In fact, my window now is going to go up to going to negative 1 and positive, let's say 35. Let's make it 35, because the reason I did positive 35 because I've got exponential decay. So decay means it's going to be going down. The 30 is going to be the highest, okay? And it's going to be reduced from there on. So let's take a look at my graph and see what we get. Now you see, again, it kind of curves, all right? So let's take a look at where we get. At 0, like we said, oh dear. Try that again. Back to the graph. And trace, there we go. So at 0, we're at 30, sure enough, y equals 30. I got 30 grams of caffeine in my system, okay? After 1 hour, I got 25.5 grams, okay? After 2 hours, I got 21.675 grams. 3 hours, I've got less than 20 grams of caffeine in my system. Now, that's not enough to keep me going. Like I said, 30 grams is barely enough for me to keep my eyes open. So, ladies and gentlemen, this is why, this curve right here, this is why I have to keep drinking caffeine. All right, seriously. What we have here is a multiplier, okay? The multiplier for exponential growth, the multiplier is greater than 1, okay? Which kind of makes sense, because if it's 1, it's going to stay exactly the same. If it's greater than 1, you're multiplying it by some number greater than 1 to a certain power, then it's going to continue to get larger and larger. Decay is when your multiplier is less than 1. In order to find your multiplier, let's suppose the population of Egypt right now, and I just looked at the website that told me, this is kind of like the thing along Aruba Street in Heliopolis, where there's a big sign that shows the population of Egypt. I just checked a website that's supposed to give us the population, and it said that this is the population of Egypt right now, 84,293,042 people. Now, if the population growth is 1.6%, okay, then the multiplier is 100 plus 1.6%, which is 101.6%, which equals 1.016. This is going to be your base, and then you put the x power. And so to find the future population of Egypt, you would say 84,293,042 times 1.016 to the x power. And if you put that function into your calculator and set your window at the right place, you're going to find out how much the population of Egypt will be in 2020, 2025, 2030, and etc. And so this is something we're going to probably experiment with in class. But I just wanted to see how that works right now. Thank you for listening. I'll talk to you later.